Let's begin lesson 2 by looking at 2a, negative exponents. Now, negative exponents for some reason can be intimidating to people, but in the past you've had something like 2 cubed. Well, 2 cubed is simply saying 2 times 2 times 2. Then you multiply that, 2 times 2, 4, times 2, 8. So you've done that in the past, easy. All the negative sign means when it's on the exponent, key is when it's on the exponent, is that you switch the side of the fraction it's on. Right now it's in the numerator, so if I wrote it like this, we would see this is in the numerator. What the negative exponent means is we simply move it to the denominator, to the bottom. So now it would look like this, 1 over 2, the sign becomes positive, cubed. So now we have 1 over 2 cubed. We already know that 2 cubed is 8, so the answer here would be 1 over 8. And that's all that a negative exponent does. It simply moves it from the numerator to denominator, or vice versa. If I had if I had 1 over 2 negative cubed, well, I would simply switch the 2 to the numerator, and that would turn the exponent positive. So that would be 2 cubed over 1 if you wanted to look at it that way. So the answer would be 8. So now I will say you can actually do these problems in your calculator. So I'll try to explain it here, do the best I can to show you. If I wanted to do 1 over 2 negative cubed, what I would type in my calculator is 1 divided by, type in 2, use the caret sign, it's the up arrow just above the division symbol. Use the caret, then put negative 3, I push enter, and I get 8. Or if I had 2 negative cubed, I would type in 2 caret negative 3, and it gives me 0.25, or sorry, 0.125, which would be 1 over 8. If I wanted to make that a fraction, I would simply push the math button, 2 buttons below the second button, and then hit fraction, enter, and then it looks like answer arrow fraction on mine, and then I hit enter again, and it gives me 1 over 8. So you can actually do these in your calculator, but I'm going to show you by hand for a few examples on negative exponents. So in A, we have 1 over 3 negative squared. I would always start these by getting rid of the negative and making those positive, so moving the 3 to the numerator or denominator, whatever needs to happen within the problem. So here we have a negative squared, so we move it to the top, so it becomes 3 squared. Everyone knows 3 squared equals 9. So your answer to A would be 9. Now we have 3 negative cubed. Negative cubed, I'm going to switch it to 1 over 3 positive cubed. 3 cubed is 3 times 3, 9, times 3, 27. So that equals 1 over 27. C, you have negative 3 negative squared. So we're going to start to get into negative symbols for the whole number, not the exponent. The exponent will still do this, go by the same rule, same principle. So I'm going to start, keep this negative here, and now I'm going to put my finger over the negative sign because we know that that is going to stay. Now it becomes negative 1 over 3 squared. So the negative squared became positive. We moved the negative symbol. So 3 squared is 9, so we get negative 1 over 9. Moving to a couple trickier ones. For D, it gives us negative 3 negative squared, but the negative 3 is in parentheses. Well, what that means, let's go ahead and switch it to 1 over 3 negative squared. We actually have to keep the parentheses because we are going to have to, instead of multiply 3, this should be a positive. Instead of multiply the 3 times 3, we are actually having to do negative 3 times negative 3, and since it's squared twice. Negative 3 times negative 3 is still positive 9, so your answer would be 1 over 9. So that's how you deal with the negatives. And then for E, you have negative 3 in parentheses, negative cubed. Start. Now this one's tricky. You got to keep this negative sign since it's outside the parentheses. Go ahead and move this to the bottom. The cubed, it becomes positive, negative 3. So then from there, you have negative 1 over negative 3 cubed. What you actually have to do is multiply negative 3 times negative 3 times negative 3 3 times. That is 3 times 3, 9, times 3, 27. You have 3 negatives, so it ends up being negative times negative positive times negative. That actually is 1 over negative 27 in parentheses. However, we have this negative sign, so now these both cross out, so this is where it's confusing. Negative and a negative equals a positive, so your answer would be 1.27. Next, let's go ahead and look at product theorems for exponents. When we say 2 squared, that means 2 times 2. You're doing 2 times itself, twice. If we were to use a variable, such as x squared, same thing. X times x. So if we had, this is the problem, x times x would equal x squared. Or if you had another problem looking like x, well, those are being multiplied, so you could say that equals x squared. Same thing for x cubed. X times x times x equals x cubed, so on and so forth. Now, the product theorem for exponents is this. X to the n power, is what we'll say right now, multiplied by x to the m power. Well, if you have two variables, two of the same variables being multiplied, but different values, then the solution is x to the power of the sum of the exponents. That is the product theorem. Now, looking, the m and the n and all that stuff may look confusing. Let's use number values. So look here. If you have x squared times x cubed, well, the x's would combine, and you would simply add the exponents together. Since the variables are being multiplied, the product theorem states that you add the exponents, so your answer would be x to the 5th power. And that's all the product theorem for exponents is. So let's look into example 2.2, and let's put these together. When solving for these, we're simplifying. When solving for these, I find the x variables. X here, and x here. Well, this one is x squared, x to the negative 5th, and x to the positive 5th. So what we simply do is add for x 2 plus negative 5 plus 5. And then that would simplify x. So when we add that, 2 plus negative 5 is negative 3 plus 5 would be 2. So x squared. So we got the x's. So we got rid of the x's. Now we're left with the y values. We have y on its own, y to the negative fourth, and y to the 0 power. Now when anything is to the 0 power, that equals 1. Y to the 0, I'll show you up here, y to the 0 power equals 1. If I had 100 to the 0 power, that equals 1. So therefore, anything times 1 is itself. So we can just go ahead and actually cross that out since it is 1. So we are left with y and y to the negative fourth. Now if y is simply on its own, I'll isolate it down here. This is what we're left with. If y is on its own, you can imagine saying that it has a power of 1. It's itself. So when you add them together, it'd be 1 plus negative 4 equaling negative 3. So you have x squared y negative cubed would be how it is simplified. Now I do want to show you one thing because we're about to get to this. So this is our answer. This could be correct. That is saying all of the, if it said to write your answer in the numerator, then this would be correct because this is over 1. It is in the top of the fraction. But what if it said to write your answer with all positive exponents? Well, just like we had before, if we had 2 negative cubed, remember the negative exponent simply means that you switch this function to the bottom to make it positive. So that would become 1 over 2 cubed. That's what we did previously. So if you have y negative cubed, and we want to make it a positive exponent, then all we have to do, right now it's over 1, all we have to do is move it to the bottom of the fraction, or in the denominator. And then it would become 1 over y positive cubed. You can't really see. 1 over y positive cubed. So then what we could say is, if we are, so this is answer in numerator. So what we would do is move the y cubed to the bottom. So it'd be x squared over y cubed would be how we write our answer with positive exponents. Sorry, I abbreviated everything. Answer with positive exponents. So either of these are correct, they are simplified, but if it asks for one or the other, that would be how you do it. Let's do one more example, just a little bit more to this one. Go ahead and create some room here. Example 2.3. Same thing. We simply have to, if it's got, the only difference is you have some on top and the numerator, some on the bottom. I would just simplify the numerator first, and then I'd simplify the denominator. So we have y negative cubed, and y to the fifth. So that's 1 minus 3, negative 2, sorry, is negative 2, plus 5 is cubed. So we got y cubed on top. For x, we have x to the fourth and x to the negative 10th. Add those together, and the sum is x to the negative 6th power. That is the numerator. Now let's do denominator. Negative 6 and 10 for y. 10 minus 6 is 4. So y to the fourth. Negative 3 and 2 for x. So therefore, x to the negative 1 power. So that's where we are at now. Now we got to simplify a little further. We still have multiple x's and multiple y's. So let's say we're solving by putting everything in the numerator. Remember, when I move something from the denominator to the numerator with an exponent, it becomes y to the negative fourth. You simply switch the sign of the exponent. So if I moved it to the numerator, now it looks like that. Add those together. 3 minus 4 is negative 1. So we're at x negative 6 over x negative 1. Y negative 1 when we add the sum. And then bring the x value to the top. So if I bring this to the top here, it becomes x. You can write the 1 if you want to, but it's implied. So 1 plus negative 6. 1 plus negative 6 would be negative 5. So x negative 5, y negative 1 would be the answer simplified. If I wanted to write it with positive exponents, I'd simply move them to the denominator. I don't think, it just says simplified, so that would work as the answer. But if you want positive exponents, you would say 1 over x to the 5th y. And hopefully that's becoming pretty easy to see the more you do it. Continuing in lesson 2, moving to the concept 2c, power theorem for exponents, is what we just did, x squared times x cubed. So your variables are being multiplied. When your variables are multiplied, you add the exponents. So this is what we just did. X squared times x cubed equals x to the 5th power. 2 plus 3, 5. Now, that was the product theorem for exponents. Now we're doing the power theorem for exponents. The difference here is we have x squared in parentheses to the power of 3, or cubed in a sense. It is not x cubed, versus x squared times x cubed. So when you have x squared in parentheses to a power of 3, what you do is multiply it. When it's a power, you multiply. So 2 times 3 is 6. So you would have x to the 6th. So notice the difference between the top when you multiply the variables and the bottom when it's a power, when the variable has a power. So the power theorem for exponents, if you have x to whatever number power, variable, or as an exponent, to the power of another variable, you would multiply them. You could also do it if you had more than one variable within the parentheses. So if you had x to the m power, y to the, or x to the m exponent, y to a, z to b, all to the power of n, you would simply basically distribute to all of the ones. And I put dot 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 because it would, it's implied that it goes on and on. So you would get x m times n, y a times n, z b times n. So let's look at these if we add numbers. X squared, y cubed, z, we'll go ahead and say 0 power, all to the power of 4. What would that be simplified? Okay, well, you distribute. 4 times 2 is 8, so you would have x to the power of 8. 4 times 3, 12. So, y to the power of 12. Well, you could look at this as 4 times 0 is 0, so you would have z to the 0 power, and that's always 1. Or you could just automatically know that z to the 0 power is 1. 1 to the 4th power is 1. So z would actually cross out. So this would be your answer. So that would be that simplified. That is the power theorem for exponents. So now let's do one quick example together. Maybe you got it that quickly, but we'll do one quick example together here, example 2.4. The first thing, just like order of operations, you would start with parentheses. Parentheses before exponents. So I'm going to find my set of parentheses. So here's one set. So like we did before, if we have a variable with an exponent to a power, you multiply. So I'll use a different color marker here. So we get x. I'm going to go ahead and write this x over here. Okay. Now we have x to the negative 6th power, because negative 3 times 2, negative 6. So we've done this one, and we've done that one. I'm going to go ahead and move this over here. Now we have everything inside the parentheses to the negative 3 power. So we multiply. Negative 3 times x to the first power, negative 3. Okay, then we have negative 3 times negative 2, y to the 6th power. So this is where we're at with the numerator. However you want to do it, doesn't matter. You could simplify. I'm going to go ahead and do the bottom. I'm going to do the denominator. Work in the parentheses, y squared to the 3rd power. Multiply that, y to the 6th. Got that done. Y negative cubed, go ahead and move that over here. And x squared to the 3rd power is x to the 6th. So now we simplify the numerator and denominator just like we did in 2b before. So we simplify x to the 1st power plus negative 6. I'm just going to go ahead and write all the numbers for x. 1 plus negative 6 plus negative 3. And you can just say minus 3 if you want. Is 1 minus 6, negative 5. Minus 3, negative 8. So we got x done on top. Y to the 1st plus y to the 6th. Y to the 7th. Then on the bottom, y to the 6th plus y negative cubed is 3. And x to the 6th. So now we are at this point. And you simply, let's solve by, let's see if it says to solve by a certain way. It just says simplify, so it doesn't matter how you do it. I'm going to go ahead and move everything to the numerator. So if I move 6, x to the 6th to the numerator, that becomes x negative 6, x negative 8. When I move this to the numerator, it becomes y negative cubed. So now everything's in the numerator, so we can add it. And negative 6 plus negative 8 is negative 14. 7 minus 3, 4. There is your answer, and that is the product theorem for exponents. Moving on to 2D, circle relationships. Some word problems here. Start just by doing example 2.5, and I'll kind of explain how to do circle relationships through the examples. 2.5, the area of a circle is 12.2 meters squared. What is the approximate circumference? Well, in order to do these problems, what you first have to know is the formula for area of a circle and the formula for circumference of a circle. Now the formula for area of a circle is pi times radius squared. The formula for circumference, we should know this. I'm going to use radius because that variable is used in both. Formula for circumference is 2 times pi times radius. Now if you notice with area and circumference, within their formulas, there's actually only one variable that you need, and that is the radius. So if we have the radius, we can figure out area or circumference. However, it does not give us the radius. So what you have to do in these problems is just look at what does it give us. This says the area of a circle is 12.2 meters. Okay, so when it says area of a circle is 12.2 meters squared, what it's actually telling us is the area is 12.2. In the past, you may have had the radius, and you're able to solve with that. Well, what we can do, since we know area is 12.2, we can actually plug the 12.2 in. I'm going to go a long route here. To the A, because A is the area. So plug that in. 12.2 equals, we ignore the variable meter squared, we don't need that, equals pi times radius squared. Well, right here we had variable of area and radius. Now we only have the variable of radius, so we can solve. And we go by, to start, I'm going to divide by pi. You're going to need your calculator for this. Divide by pi on both sides, so they cross out there and cancel. Use my calculator. 12.2, I'm going to go ahead and just divide by 3.14. That is 3.89, and I'm rounding. So 12.2 divided by pi is 3.89, and that equals radius squared. Now, when you're solving, all you have to do is the opposite function. So if something is squared, the opposite of something being squared is to square root. So we square root r squared, and what we do to one side, we have to do to the other. Square root both. So now that crosses out, so r equals square root of 3.89. Once we get to that, we just type that in our calculator, square root of 3.89 equals 1.97. So radius equals 1.97. Now, did we solve the problem? No, it asked for what's the approximate circumference. However, we do have the radius, and so now all we have to do, I'm going to use one more marker color to keep it organized. Now all we have to do is plug in the radius for our circumference. Or sorry, the radius and the formula for circumference for the circle. So we plug it in, and we got 2 times pi times radius, which is 1.97. 2 times pi times 1.97 equals your circumference. And then you simply multiply all that. So we got 2 times 3.14 times 1.97, and that is 12. That is a little cluttered. I'm going to go ahead and write the answer over here. 12.37. Now our measurement value was meters. Circumference, remember that's just perimeter of the circle. So we just had 12.37 meters. We found the circumference, not the area, so it just stays in meters. So that's how you do circle relationships. So we'll try one more, and this one is just switched. It gives us the circumference and asks us to solve for the radius. I'm going to remove some of the clutter. No, probably shouldn't embrace it. Okay, so the formula for area, pi r squared. Formulas for circumference, 2 pi r. Now we plug in what we know. We know the circumference is 8 pi. Circumference, C, equals 8 pi. So 8 pi equals 2 times pi times radius. Now this one's going to be nice and easy because to get r by itself, we can divide by 2 times pi. They both cross out over here. Divide by 2 pi over here. Well, this is easy. The pi's cancel out. Pi divided by pi is 1. 8 divided by 2 is 4. So your radius is 4. Now, once again, it asks what is the area of a circle. So we actually need to find area. So we simply plug in the radius of 4 to our formula for area. Area equals 4 times, area equals pi radius squared. Pi times 4 squared. 4 squared is 16. So then you multiply 16 times pi and that is 50.27 rounded. I actually multiplied by pi on that one. The measurement, let's see, is centimeters. Centimeters squared. Always remember to put your measurement. Got to know what you're measuring. Centimeters, meters, inches. Got to know what it is. But that is circle relationships, and that concludes lesson 2.